Hello all, welcome to Unacademy. Today we will continue our last lecture, that is differential equation. In the last lecture we have seen how to find out the roots of differential equation and how to find out the solution of the differential equation. Okay, in that we will find out the solution for the non-homogeneous differential equation with there are three methods. First is general method, second is shortcut method, third is method of variation of parameter. But in the general method, yesterday we have completed in the last lecture that the first method is completed, general method. Okay, in that method, how to find out the solution for the given differential equation, we have already covered it. Now in this lecture we will going to see the next rule for the shortcut rules, whatever the remaining rules, and the next method, that is method of variation of parameter, that we will cover up in this lecture. So before going to start this lecture, I will introduce myself Dhanashree Palasdeokar. I completed my MSc in Mathematics from Mumbai University, and I am having 13 plus years of teaching experience, and I also mentored more than 10,000 plus students for the engineering maths. Okay. Now, before going to start our actual topic, let me introduce how to install the Unacademy's learning app within 1 to 2 minutes. Okay. Now, what the step one is, you have to go to your mobile Play Store app, and search the Unacademy learning app. You will see the icon, the blinking arrow that will appear on your mobile screen, and then go through it and install the Unacademy's learning app. After this, you have to manage your goal. It means for which course you want to study, that course you have to manage your here. It means जैसे कि हम लोग अभी यहाँ पे गेट एंड ईएससी के लिए पढ़ रहे हैं, you have to manage your goal. That is, if you want to study for the NET exam, GATE exam, whatever you want to study, that you have to manage here. And then after that you have to take the subscription. Either you can take the subscription plus subscription, free courses, special classes, whatever you want, you can take it. And after that, get the subscription, press the get subscription button, so that your app is installed in your mobile. And next is, if you want to select, if you want to learn for the how many months, it means if you want to manage your course for or you want to take the subscription plans for 12 months, 24 months, whatever you want to take, you can select over here. And the most important thing is here that if you want to 10% discount on your subscription fees, so please use my promo code, that is DSP, so that you will get a 10% discount on it. So we can use here uh, my promo code, that is DSP, to get the 10% description on it. Okay, after that you can pay the bill or pay the subscription fee by using any one of this method. Either you can use debit card, credit card, EMI, UPI, wallets, net banking, anything you can use here to pay the subscription fees. Okay. Now, see, as I told you in the last lecture, we already studied the linear differential equation with constant coefficient. In that I covered first method, that is our general method. In that I covered general method, how to find out the solution for that. So we will take a short recap on that general method. So first, if the differential equation is in this type dy, then by using general method you can write here yp is equal to 1 upon f of d into x, that is 1 upon d into x, that is 1 upon d is nothing but the integration of d into x. Now, second one, we can manage d minus a into y, which is equal to yp is equal to 1 upon d minus a into x, which is equal to here e raised to ax into integral of e raised to minus x into x dx. Okay. Third one, d plus a of y is equal to yp is equal to 1 upon d plus a into x is equal to, just take the opposite side outside of that. So these are the formulas to find out the solution when by using general method. Okay, in this general method we will find out by using this. So now the next one is shortcut method. We will use shortcut method here. So I covered up each type of example on this in the last lecture. If you want, you can go through it. Okay? No. Here we can try the shortcut method. Second method we have seen the shortcut method. Here we used the shortcut method. Okay, in this shortcut method we use first one, rule 1. I'm just covering the last lecture. That is, in that rule, if your x is equal to e raised to x, then replace your, so we can write yp as here 1 upon f of d into e raised to x. 1 upon f of d into e raised to x. So replace d by here a. So 1 upon f of a into e raised to x, provided f of a is not equal to 0. If f of a is equal to 0, then we can find out yp is equal to x upon f dash of a into e raised to x. Okay, provided f dash of a is not equal to 0, and so on. So similarly, we calculate here, we solved one examples on this rule, depending on this rule yesterday. Now, second rule is there. This rule we also required in this lecture, so that's why I'm recovering it. So rule 2, if x is equal to sine ax plus b or cos ax plus b, then we can find out yp is equal to 1 upon f of minus of d square f of d square, yeah, into e raised to sine of x plus b or cos of x plus b, which is equal to f of minus of d square into sine ax or cos x, sine ax plus b or cos ax plus b. Okay, so in this way, provided f of minus of d square, so here minus of d square, you can write here minus of a square, f of minus of a square. So provided f of minus of a square is not equal to 0, and so on. If it is equal to 0, then we can use x upon f dash of minus of a square into sine ax plus b or cos x plus b. Okay, in this way we will go through it. Now the rule 3 is exactly similar to rule 2. We will take rule 3 here. Okay. We will take a short review on the last lecture. So we can write here rule 3. So rule 3 is for x is equal to sin hax or cos hax, then we can write yp is equal to 1 upon f of d square into sin hax, which is equal to 1 upon f of a square. Only minus of a square, here we can write f of a square. Okay, So 1 upon f of x square into sin h ax or cos h x. That's it. We covered in the last lecture everything. We covered it, how to find out the yp. Now as we know that how to write the yc, when the roots are real and distinct, roots are real and repeated, roots are complex and repeated roots. So everything we will cover up here. Okay, now see, here we will see f of x is equal to whenever the roots are real and distinct, then we can write yc is equal to c1 e raised to m1x plus c2 e raised to m2x plus and so on plus cn e raised to mnx. Okay, if the roots are real and distinct. Okay, second one, if the roots are yc is equal to c1 plus c2 x e raised to m1x plus c3 e raised to m2x c3 e raised to m3x plus and so on plus cn e raised to mnx. Okay, now so yc is equal to this, so we will get yp again. Yc is equal to, if the roots are this, if the roots are real and repeated, if the roots are real and repeated, and if the roots are complex, then we can write yc is equal to e raised to alpha x into bracket c1 cos beta x plus c2 sin beta x. Okay, if the roots are complex, then we can write this roots are complex. If the roots are complex, okay, okay. Now in this lecture we will cover up the next rule, that is, and one more type of here. If the roots are complex repeated, then we can write e raised to alpha x into bracket c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. Okay, now moving forward, we will see the next rule, that is, if x is equal to x raised to m, then how to find out the yc and yp. Okay, so 1 upon f of d into x raised to m into f of d inverse x raised to m. Expand f of d raised to minus 1 in the ascending powers of d up to the highest power of d is m, and then operate on x raised to m. Now here 1 plus z bracket raised to minus 1, which is equal to 1 minus z plus z square minus z cube plus z raised to 4 minus and so on. Okay, now 1 minus z bracket raised to minus 1 is equal to 1 plus z square plus z cube plus z raised to 4 plus and so on. Okay, we can expand like this. Now we'll see first example of this type. Okay, so here solve d square plus 5d plus 4 of y is equal to x square plus 7x plus 9. Okay, so here your auxiliary equation is, okay, auxiliary equation is d square plus 5d plus 4 is equal to 0. Okay, so what are the roots of this? D square plus 5d plus 4 is equal to 0. So we can write d square plus 4d plus d plus 4 is equal to 0. So which implies d into bracket d plus 4 plus 1 into bracket d plus 4 is equal to 0. So which gives us d plus 4 into d plus 1 is equal to 0. Okay, which gives us d plus 4 into d plus 1 is equal to 0, which implies d plus 4 is equal to 0 or d plus 1 is equal to 0. Okay, so d plus 4 is equal to 0, it means, which implies d is equal to minus 4. D plus 1 is equal to 0, which implies d is equal to minus 1. Okay, now the roots are d is equal to minus 4 and d is equal to minus 1 are real and distinct. Therefore, we can write yc as c1 e raised to minus 4x plus c2 e raised to minus x. Now we will find out yp. Now see how we can find out the yp here. See, so here is the power of x. X square is the power. Okay, so instead of writing separately, what we will do, see here, we will do, so yp is equal to 1 upon f of d into x. Okay, so moving forward, so yp is equal to 1 upon f of d. So what is our f of d? D square plus 5d plus 4 into x square plus 7x plus 9. X square plus 7x plus 9, which is equal to 1 upon 4 plus 5d plus d square into x square plus 7x plus 9. Okay, so we will convert it into either 1 plus z or 1 minus z form. So here we will convert 1 plus z form. Okay, so take the 4 common, so you will get 4 into bracket 1 plus 5d plus d square by 4 into x square plus 7x plus 9. Okay, so you will get 1 by 4 into 1 plus 5d plus d square by 4 bracket raised to minus 1 of x square plus 7x plus 9. Now as I told you, you can expand this 1 plus z bracket raised to minus 1 in the form of, expand in the form of here 1 plus z, 1 minus z plus z square plus z cube minus z raised to 4 and so on, alternate plus minus sign. So here z, your z is nothing but here 5d plus d square by 4. Okay, so we can expand 1 by 4 into bracket 1 plus 1 minus z. So that is 5d plus d square by 4 plus, now we will expand up to the highest power of m. So here highest power of m क्या है यहाँ पे, x is m is equal to 2. So we will expand up to 2. So 5d plus d square by 4 raised to 2. Okay, and minus and so on. So we will keep as it is here, x square plus 7x plus 9. Okay, now simplify this. So you will get yp is equal to 1 by 4 into bracket 1 minus 5d by 4 minus d square by 4 minus d square by 4 plus 1 by 16 into bracket 5d plus d square square. So 25d square, right? You will get 25d square and plus a square plus 2ab 10d cube. So we will omit that term. So why we will omit that term, that explain you in the previous step. See, then d raised to 4 also we will exclude. Okay, because we required up to the highest power of this. So we will get 25x square of, now here x square plus 7x plus 9. Okay, so you will get yp is equal to 1 by 4 into bracket 1 minus 5 by 4d plus d square by 4 plus 25 by 16 d square. Okay, so what we will do, of x square plus 7x plus 9. So yp is equal to 1 by 4 into bracket 1 minus here 4d square plus 25d square. So minus 5 by 4d plus 4d square plus 25d square upon 16 of x square plus 7x plus 9. Okay. Now, if you see this, so we will get separate out, we will apply. We will separately apply 1 by 4 into bracket 1 into this, so x square plus 7x plus 9, just multiply, minus 5 by 4 into d of x square plus 7x plus 9 plus, now here 25 plus 4, that is 20, here we'll get minus, oh sorry, here is our d square minus n. So minus d square plus 25. Plus 21 d square by 16 x square plus 7x plus 9. Okay. So here is 1 by 4 of, up now we will see how to calculate this. See, I am calculating here d square here. Your x square plus 7x plus 9. So your first order derivative of this is d is 2x plus 7. D square is 2. And if you see d cube is equal to 0. Here d cube is equal to 0. So you will get yp is equal to 1 by 4 into bracket x square plus 7x plus 9 minus 5 by 4 into d of x square plus 7x plus 9. So that is here d of x square plus 7x plus 9 is 2x plus 7 minus plus 21 by 16 d square of plus 21 by 16 d square of, that is 2. Okay, so you will get 1 by 4 into bracket x square plus 7x plus 9 minus 5 by 2x minus 35 by 4 plus 42 by, so here we can write 21 by 8. Okay, so ultimately we will get 1 by 4 into bracket x square, here minus 5 by 2x and here 7x, so 14x minus 5x, so plus 9x by 2. Okay, minus, this is minus plus 9 plus 9 minus 35 by 4 plus 21 by 8. So 1 by 4 x square plus 9x by 2, 36 minus 35, that is 1 by 4 plus 21 by 8, 1 by 4 plus 21 by 8. So here I can write 223 by 8 directly. Okay, so 23 by 8, this is your yp. Now what will be our y? Y is equal to yc plus yp. So our y is equal to yc plus yp. So yc is c1 e raised to minus 4x plus c2 e raised to minus x. c1 e raised to minus 4x plus c2 e raised to minus x plus 1 by 4 into x square plus 9x by 2 plus 23 by 8. Okay, so y is equal to this. So this is your final answer. Okay. Example to see. Solve d square minus d plus 1 of y is equal to x cube minus 3x square plus 1. Okay. Now, first of all, find out yc. So, auxiliary equation is d square minus d plus 1 is equal to 0. Now, we see it is in the power of x raised to m. So, use rule 4. Use rule 4. So, d square minus d plus 1 is equal to 0. So, you will get, now see, Here you will get d is equal to, so here you can find out d as d is equal to minus b plus or minus under root of b square minus 4 into s upon 2a. So minus 1 plus or minus square root of 1 minus 4, that is minus 3, root of minus 3 upon 2. Okay, so root of minus 3 upon 2. So we will get here minus 1 plus or minus root 3i upon 2, because root of minus 1 is I. So you will get minus 1 plus or minus root 3i upon 2. Now d is equal to, here you will get d is equal to, so roots are complex and distinct. Okay, so you can write yc as alpha raised to, now here alpha is minus 1 by 2. Here alpha is equal to minus of minus 1, so it will becomes plus 1. So e raised to alpha x c1 cos beta x, beta is root 3 by 2x, plus c2 sin beta x, beta is root 3 by 2x. Okay, so c1 cos alpha beta x plus c2 sin beta x, this is your yc. Now we will find out yp. So what is the formula of yp? Yp is equal to 1 upon f of t into x. So which is equal to 1 upon d square minus d plus 1 into x. X is x cube minus 3x square plus 1. Okay, here it is x cube minus 3x square plus 1. So you will get yp is equal to, here yp is equal to 1 upon, we can write this as 1 plus d square minus d into x cube minus 3x square plus 1, x cube minus 3x square plus 1. Now what is the highest power of x here? M is equal to 1. Here highest power of x, that is m is equal to here 3. So you will get here m is equal to 3. So 1 upon 1 plus d square minus d is, so you can write 1 upon 1 plus d square minus d, as you can write here 1 plus d square minus d bracket raised to minus 1. Now this is your set. So again you can apply the 1 minus 1 plus z bracket raised to minus 1. Okay. So expand like a z. Now this will be becomes your z. Okay. So 1 plus z d square minus d raised to minus 1. So you will get 1 plus. Now we will expand up to the highest power of x, that is x raised to m. Okay. So 1 plus, here 1 minus z plus d square minus d bracket square minus d square minus d bracket raised to 3. Okay, of, we will expand up to the highest power of, and that is here. So we will get x cube minus 3x square plus 1. So 1 minus d square, 1 minus d square minus minus plus d, plus d raised to 4. We will exclude it, d raised to 4, because it is power greater than 3. So we will exclude greater than 3, because if you take it here, again the calculation effort bits becomes increasing. If you omit here only d raised to 4, then it will be easy to do the calculation, because ultimately d raised to 4th power is equal to 0. If you observe, you will get the d raised to 4th power, that is 4th order derivative will be 0. So we are excluding here. So d square minus d of bracket square. So you d raised to 4 omit here. So again you will get 2d cube. A minus b bracket square. So a square minus 2ab a square minus 2, because a square here d raised to 4, so that we will be omit, minus 2ab, so minus 2d raised to 3, and minus plus d square, a plus b bracket raised to 2, a plus b, a minus b bracket square, we will expand like this, so a square minus 2ab plus b square, here your a is equal to d square and b is equal to d, so you will get minus 2d cube, d cube, because d raised to 4, d square raised to 2, d raised to 4 we will omit it, so minus 2d cube plus d square. Okay, now minus here again d cube, d square raised to 3, so d raised to 6, so that will be again omitted, so you will get only here 1 minus, see d, so you will get d raised to 2 bracket a minus b brackets cube. So a cube minus 3a square b plus 3ab square minus b cube, right? So you will get here a cube minus b. So d raised to 2 minus d bracket cube. So d raised to 6. So we will omit it here. So 3 into d square into 3 into a square, again it is omitted, then 3 into a into b square, so again it is omitted, so b cube, so we will write here only d cube. Okay, so d cube is also again, here we will take d cube, so minus of d cube. Okay, so you will get here ultimately you will get 1 plus, here you can write x cube minus 3x square plus 1. Okay, 1 minus d square and plus d square get cancelled out. Plus d. Okay, now minus d cube and minus minus plus d cube. So minus 2d cube plus d cube becomes minus d cube of x cube minus 3x square plus 1. Now we will calculate. Here yp is equal to 1 plus d minus d cube of x cube plus 3x cube minus 3x square plus 1. Okay, so we will calculate the d cube and this. So here x cube minus 3x plus 1, we will cross verify once again. So d it means d by dx. So first order derivative of this, that is 3x square minus 3 plus 0. Okay, now d square is 6x and d cube is equal to 6. Now why I am not taking d raised to 4, are you getting it? If you take it d raised to 4, no issue, but ultimately that derivatives of d raised to 4 of that x cube minus 3x square plus 1 is equal to 0. So why we will write, we will reduce our efforts and keep only as it is. So you will get yp is equal to 1 into this. So x cube minus 3x square plus 1 plus d of x cube minus 3x square plus 1 minus d cube of x cube minus 3x square plus 1. So x cube minus 3x square plus 1 plus what is d of this, that is 3x square minus 3. So directly I can write 3x square minus 3 minus d cube of this. So d cube of this is 6. So directly you can write 6 here. Okay. Now, so x cube minus 3x square plus 3x square will get cancelled out. So you will get minus 3x square plus 3x square is equal to, okay, here is minus 3x square. So you will get here 6x minus 6x. Okay, so d of this is minus 6x. The d square of this is only 6x. So x plus 3x square minus 3x square, so minus 6x and plus 1 minus 6, that is minus 5. So your yp is equal to this. So again y is equal to yc plus yp. So your final solution is e raised to 1 by 2x, e raised to 1 by 2x. Here we can write directly y is equal to, we'll talk about this, yc plus yc, you can write yc plus yp, which is equal to y is equal to yc is c1, yc is equal to e1 e raised to 1 by 2x into c1 cos root 3 by 2x plus c2 sine root 3 by 2x plus yp is x cube minus 6x minus 5. X cube minus 6x minus 5. This is your complete solution y. Okay. Now we will find out. Now we will see the next rule, that is rule 5. Whenever your function x is given in the form of e raised to ax into v, where v is again a function of x, okay, where v is again a function of x, then how to find out yp? Okay, what we will do in that rule? If we will do that 1 upon f of d into e raised to x into v, then we can write e raised to x into 1 upon f of d plus a into v. It means wherever there is d, we can replace that d by a. Okay, to use the rule 5, see, we will go through it. Now we will see first example of this type. Now d square minus 4d plus 4 of y is equal to e raised to 2x into sine 3x. Okay, e raised to 2x into sine 3x. So you will get d square minus 4d plus 4 of y. So auxiliary equation is d square minus 4d plus 4. So you will get d minus 2 bracket square is equal to 0, right? So ultimately you will get d is equal to two repeated roots of these differential equations are repeated, real and repeated. Therefore we can write yc as yc is equal to c1 plus c2x e raised to 2x. This is our yc. Okay, I hope you are clear. So yc is equal to c1 plus c2x into e raised to 2x. Okay, now we will find out yp. So what will be our yp? Yp is equal to 1 upon f of d into x. So 1 upon f of d. So what is our f of d? F of d is d square minus 4d plus 4. So instead of that, can I write d minus 2 bracket square of y? So why I am telling you, why I am writing like this? Okay, d minus 2 bracket square, that is your f of d into x. X is your e raised to 2x into sine 3x. E raised to 2x into sine 3x. So what we will do here, e raised to 2x into sine 3x. So we will apply rule 5. Okay, apply rule 5. So what's it that? So replace d by d plus a. So what is our a here? A is 2. This is our a. So replace this d by d plus a. It means your yp becomes 1 upon, see here, e raised to 2x into d plus 2 minus 2 bracket square of sine 3x. It's a very simple. So you will get here yp is equal to e raised to 2x into plus 2 minus 2 get cancelled out. So it is 1 upon d square into sine 3x. Okay, 1 upon d square into sine 3x. So what you will get? Yp is equal to e raised to 2x into 1 upon d square into sine 3x. So now here we will again apply the rule 2. Either you can integrate double integrate here, integration of sine 3x, and then otherwise we will use the shortcut rule 2. So what is our shortcut rule? If in the f of d square, replace here f of d square is equal to minus of a square. So here our a is equal to 3. Okay, so we can write yp is equal to 1 upon, sorry, here e raised to 2x into 1 upon d square into sine 3x, right, into sine 3x. So here d is equal, a is equal to 3, a square is equal to 9, so minus of a square is equal to minus of 9. So you will get yp is equal to e raised to 2x into 1 upon d square is equal to minus of a square, that is minus 9 into sine 3x. Now this is your yp, that is yp is equal to, we can write minus 1 by 9 into e raised to 2x into sine 3x. It is very simple to calculate the yp by using rule 5 when the integrand is given in this way. Now you just think of that, if you use to going to the first method, that is general method, it's a very difficult to find out the integration of this. Okay, again it means you have to apply here by parts 2 times. Now, so the total solution y is equal to yc plus yp. Our total solution is y is equal to yc plus yp. So what is our y? Y is equal to, you will get here y is equal to yc. So yc is c1 plus c2x e raised to 2x. c1 plus c2x into e raised to 2x plus here minus 1 by 9 minus 1 by 9 into e raised to 2x into sine 3x. Minus 1 by 9 e raised to 2x into sine 3x. Okay, this is our total solution for the given differential equation. Okay, so I hope you are clear here. The rule 5, we will solve one more example on this type. See, I covered this example. Here we will use the many rules, okay, to solve these examples. Now see the rule of 5 here, so that you will clear how we are using here the rule 6, rule 5. Okay. Here we will use rule 5. So e raised to minus 3x, e raised to 3x. Okay. So d square plus 6d plus 9 of y is equal to this. So auxiliary equation is d square plus 6d plus 9 is equal to 0. So ultimately we will get d plus 3 bracket square is equal to 0. So which implies d is equal to minus 3 minus 3. So roots of these differential equations are real and repeated. Okay. So you can write yc as yc is equal to c1 plus c2x e raised to minus 3x. Okay, yc is equal to c1 plus c2x into e raised to minus 3x. This is our yc. Okay, now yp. Yp is equal to 1 upon f of d into x. So 1 upon f of d. What is our 1 upon f of d? 1 upon, so can I write directly here d plus 3 bracket square? So it's a very simple. So why, see, you can use directly here d square plus 6d plus 9, but we will, our calculation efforts will be more if you write that. If you write in this way, so you definitely your calculation efforts are reduced. So e raised to minus 3x into x cube plus sine 3x. E raised to minus 3x into x cube plus sine 3x. Okay, here your a is equal to here minus 3. So I am writing e raised to minus 3x and replace d by d plus a. But here पे a है minus 3. So you can write instead of d minus 3 plus 3 bracket square into x cube plus sine 3x. Okay, so this will becomes e raised to minus 3x into 1 upon plus 3 minus 3 cancel out d square into x cube plus sine 3x. Now what we will do, we will separate out this 1 upon d square. Okay, we will separate out this 1 upon d square, or otherwise we can take the integral of 2 times. See, instead of using that x raised to m rule, it's a better way to apply the integration. So you can use any one method, either you can integrate it or you can use the rule, okay, 4 and rule 2. Okay, but I am here using directly integration. See, yp is equal to e raised to minus 3x into 1 upon d square of x cube plus sine 3x, x cube plus sine 3x. Okay, so e raised to minus 3x, e raised to minus 3x, 1 upon d square is nothing but double integration of x cube plus sine 3x into dx. Okay, so you will get e raised to minus 3x into integration of, now integration of x cube is x raised to n ka integration, x raised to n plus 1, that is 3 plus 1 upon n plus 1, that is 4, plus इंटीग्रेशन ऑफ साइन u, तो क्या हो जाएगा माइनस कॉस u अपॉन डेरिवेटिव ऑफ u, that is 3, right? So minus cos 3x by 3. Now again we have to integrate this. So you will get e raised to minus 3x into integration of this x raised to 5 upon 5 into 420 minus integration of cos x, क्या बन जाएगा sin 3x. So only sin 3x by 3 into 3, 9. So sin 3x by 9. So this is your yp. I hope you are clear. Now we will write down total solution y is equal to yc plus yp. So our y is equal to yc plus yp. So what is our y? yc? yc is c1 plus c2x e raised to minus 3x. c1 plus c2x into e raised to minus 3x. Okay. And yp is e raised to minus 3x into bracket x raised to 5 by 20 minus sin 3x by 9 minus sin 3x by 9. This is our y. This is our complete solution for the given linear differential equation with constant coefficient. Okay, this is our linear differential equation with constant coefficient. Solution for the given linear differential equation with constant coefficient. I hope you are getting clear the rule one by one. I am solving two examples of each type so that you will get a clear-cut idea how to solve the given differential equation. Okay, now we will see the next rule, that is rule 6. If x is equal to x into v, where v is a function of x, then we will see if x is equal to x into v, where v is the function of x, then how to find out the uh, solution for the given differential equation if your x is in the form of x into v. So 1 upon f of d into x into v is equal to x minus 1 upon f of d into f dash of d into 1 upon f of d into v. That rule we must remember, 1 upon f of d into x into v is equal to x minus 1 upon f of d into f dash of d into 1 upon d f of d into v. Okay, now we will see. First example of this type. Now d square minus 1 of y is equal to x into v. See here x into sine 3x. So here your sine 3x is treated as v. X into v, where v is a function of x. Okay, so what is our first job? Our first job is to find out the yc. Okay, so I hope you are clear here how to find out the YC. So the auxiliary equation is d square minus 1 is equal to 0, f of d is equal to 0. So which implies d square is equal to 1. So which implies d square is equal to plus or minus 1. Okay, sorry, d is equal to plus or minus 1. So the roots are real and distinct. Roots are real and distinct. Therefore, we can write yc is equal to c1 e raised to x plus c2 e raised to minus x. This is our yc for the given differential equation. As this is non-homogeneous, so we will calculate yc as well as yp. Now we will use to find out the yp rule 6. Okay, x into v. So what is our rule? X into v is equal to x minus 1 upon f of d into f dash of d whole bracket multiplied by 1 upon f of d into v. Now see. So here we will calculate yp is equal to 1 upon f of d into x. Okay. So yp is equal to 1 upon f of d. So what is our f of d? F of d is d square minus 1 into x into sine 3x. Okay, now we will apply the rule 6. So yp is equal to x minus 1 upon f of d, d square minus 1 into f dash of d. राइट, हमारा रूल क्या है? x into v का. So x minus 1 upon f of d into f dash of d into 1 upon f of d into v. Right? So we will write here 1 upon d square minus 1 into f dash of d. f dash of d होगा d square का डेरिवेटिव 2d, कांस्टेंट का डेरिवेटिव 0 into 1 upon f of d. f of d is d square minus 1 into sine 3x. Okay, 1 upon d square minus 1 into sine 3x. So x into 1 upon d square minus 1 into sine 3x minus 1 upon d square minus 1 bracket square 2d into 2d of sine 3x. Okay, I hope you are clear up to this step. X into, I am multiplying separately, x into 1 upon d square minus 1 into sine 3x minus x into 1 upon d square minus 1 into 1 upon d square minus 1, that is bracket square, into this 2d into this sine 3x. Okay, now we will get yp is equal to here x into 1 upon d square minus 1 sine 3x. So here we can use the rule 1. Okay, so x into 1 upon, I am writing this yp as it is in the next step so that it will be more clear to find out this yp. Yp is equal to x into 1 upon d square minus 1 into sine 3x. Okay, minus 1 upon d minus 1 bracket square 2d into sine 3x, here 2d into sine 3x. Okay, so yp is equal to x into, now here we will use rule 2 here. Okay, here a is equal to 3. Okay, a here a is equal to 3 for this. A is equal to 3, a square is equal to 9 and minus of a square is equal to minus 9. So what we will do? We will do x into minus 9 minus 1 into sin 3x minus 2d upon, now here d minus 1 bracket square. Okay, so d minus 1 bracket square. So can I expand this d minus 1 bracket square like this? Just a minute, here d plus 1 or d minus 1? Okay, d minus 1. So we can use here d minus 1 bracket square 2d into sin 3x. So you can write directly here minus 1 into sin 3x and put d square is equal to minus 9. So minus 9 minus 1 minus 10 square, that is 100 into sin 3x. Okay. So x upon minus 10 into sin 3x minus 2 by 100, it means minus 1 by 50, and d of sin 3x, it means derivative of sin 3x. D, it means d by dx. So derivative of sin 3x is 3 into cos 3x. Okay, derivative of sin 3x is 3 into cos 3x. So your yp is equal to x upon minus 10 sin 3x minus 3 upon 50 into cos 3x. I hope you are getting it. Now your final answer y is equal to here yc plus yp. So y is equal to yc is, here our yc is c1 e raised to x plus c2 e raised to minus x. c1 e raised to x plus c2 e raised to minus x plus or minus x by 10 sin 3x minus 3 by 50 cos 3x. This is our y is equal to yc plus yp. Okay. No, I hope you are clear here this example. Once again you will go through it. So it's very simple step first to find out the auxiliary equation. What is square minus 1 is equal to 0, and then find out the roots are real and distinct here. So roots are real and distinct. Then we can write easily yc as yc is equal to c1 e raised to x plus c2 e raised to minus x. Okay, so your yp, formula for yp is 1 upon f of d into x. So here yp is equal to 1 upon f of d. Here f of d is d square minus 1 and your x is x into sin 3x. Okay, so here we will use x into b rule. So x minus 1 upon f of d into f dash of d. So derivative of d square minus 1 is 2d into 1 upon f of d. So that is d square minus 1 into sin 3x. So here yp is equal to x into 1 upon d square minus 1 into sin 3x. I'm just multiplying with this. Okay. So minus this minus and 1 upon d square minus 1 into 1 upon d square minus 1 becomes 1 upon d square minus 1 bracket square into 2d into sin 3x. Okay. So 2d into sin 3x you will get here yp is equal to x into 1 upon d square minus 1 into sin 3x. So here your a is equal to 3. So a square becomes 9 and minus of a square becomes minus 9. Here we use rule 2. So 1 up x into 1 upon minus 9 minus 1 into sin 3x. So minus 2d into minus 9 minus 1, that is minus 10 bracket square 100 into sin 3x. So x upon minus 10 into sin 3x minus 1 by 50 into derivative of sin 3x, that is minus 3 by 50 cos 3x. Okay. So y is equal to yc plus yp. So y is equal to c1 e raised to x plus c2 e raised to minus x minus x by 10 into sine 3x minus 3 by 50 into cos 3x. I hope you are totally clear this rule 5 and rule 6 also. And in this rule 6 we are using rule 2 also. Now see again the similar type example. Just we will take a quick recap on that. Now see. So auxiliary equation is d square plus 1 is equal to 0, which implies d square is equal to minus 1. So d is equal to plus or minus I. This is very simple. So you will get our yc is equal to, here alpha is equal to 0. So e raised to 0 alpha x. So that is e raised to 0 x is 1. So c1 cos x plus c2 sin x. So yc is equal to c1 cos x plus c2 sin x. Okay. So yc is equal to this. Now we will find out yp now. So again here your rule, we will apply the rule u into v. So yp is equal to 1 upon f of t into x. So 1 upon d square plus 1 into x into cos 2x. Now just use that rule exactly similar way as we have done in the previous example. That is 1 upon, here d square plus 1. So you can write here x minus 1 upon d square plus 1 and f dash of d is 2d into v. V is cos 2x. Okay. So here you will get x into 1 upon d square plus 1 into cos 2x minus 1 upon d square plus 1 bracket square. Just multiply करते जाना है ना, 2d of cos 2x. So यहाँ पे हम लोग रूल 2 यूज करेंगे because sin x and cos 2x के लिए रूल सेम है. So here your a is equal to 2, a square is equal to 4 and minus of a square is equal to minus 4. So just imply here d square is equal to minus of a square, that is minus 4. So x into 1 upon minus 4 plus 1 into cos 2x minus, here also same. So d square is equal to minus 4. So minus 4 plus 1 minus 3 square, that is 1 by 9 into 2d of cos 2x. Okay. So x upon minus 4 plus 1 minus 3 into cos 2x minus 1 by 9, 2 into 2 by 9 as it is, and d it means d by dx of cos 2x. So d by dx of cos 2x is, d by dx of cos 2x is minus 2 sin 2x, right? So you will get yp is equal to, our yp is nothing but here minus x by 3 cos 2x minus x by 3 cos 2x minus minus plus 4 by 9 sin 2x plus 4 by 9 sin 2x. This is our yp. Okay, yp is equal to this minus x by 3 cos 2x plus 4 by 9 sin 2x. Now y is equal to becomes, y is equal to yc plus yp. So here our y is equal to, we will get y is equal to, yc is c1 cos x plus c2 sin x plus yp is minus x by 3 cos 2x plus 4 by 9 sin x. Okay, this is our y. If our y is equal to this. So we will get y is equal to this. Now we will see our next method, that is method of variation of parameter. Okay, first we will just read it. I will come within 2 minutes. Okay, just go through it. See, method of variation of parameter. What do you mean by method of variation of parameter? This is our third important method to find out the solution for the given differential equation. Now see, the simplest method or simplest way to find out the solution for the differential equation is shortcut method. Okay, in that method you can find out the a solution for order of any differential equation. Order of the differential equation is greater than 2, greater than 3, greater than, or order of the differential equation is either 2, 3, 4, 5, anything you can use. In that case, for the shortcut method is very easy to implement. Okay, but here method of variation of parameter is restricted method. It means this method is applicable only for the for the order of the differential equation is 2 and order of the differential equation is 3. We can use apply only for these two types of methods. Okay, either it is of order 2 or it is of order 3. You cannot apply this method for the order greater than 3 or less than 2. Are you getting it? The simplest method among all the three methods is the shortcut method. You can solve any example of differential equation with constant coefficient by using that shortcut method. Okay. Now here method of variation of parameter. We will see one by one the steps. Here the differential equation is f of d of y is equal to x and complementary function is yc is equal to c1y1 plus c2y2, then yp is equal to uy1 plus vy2. Right, where u and v are functions of x, u dash and v dash satisfies the equation, where u dash y1 plus v dash y2 is equal to 0 and u dash y1 dash plus v dash y2 dash is equal to x. Note, u is equal to integral of minus y2 into x upon d dx, where v is equal to integral of y1x upon d dx, where d is the determinant of y1, y2, y1 dash and y2 dash, and that determinant is called as a Wronskian. Okay, now also if yc is equal to, now this step is only for the, up to this step we can solve the differential equation of order 2. Okay, when we are getting C1 y1 and C2 y2, if the order of the differential equation is 2. Okay, then at that time we can find out the yp by using yp is equal to uy1 plus vy2. Right, now see, when the order of the differential equation is, you can see here, if the order of the differential equation is greater than 3, then you can easily see that here yc is complementary function, or yc is equal to c1y1 plus c2y2 plus c3y3, then yp is equal to uy1 plus vy2 plus wy3, and we will see how to calculate the u, v and w when it is given in the, and this u, v, w satisfies these three equation also. Okay, here is equal to 0, not x, here is 0, it's a printing mistake, here must be, it is 0. Okay, now where u, v, w are u is equal to integral of determinant of y2 y3 y2 dash y3 dash into x upon d and dx, where this determinant you can calculate y2 into y3 dash minus y2 dash into y3 upon d into x into dx. Okay, where v is equal to, here we can write, where v is equal to minus of integral of determinant of y1 y3 y1 dash y3 dash x upon d into dx is equal to minus of integral of y1 into y3 dash minus y1 dash into y3 upon d into x dx. Okay, and w is equal to integral of determinant of y1 y2 y1 dash y2 dash into x upon d dx is equal to integral of, now solving this determinant, y1 into y2 dash minus y1 dash into y2 upon d into x dx. Okay, where d is the determinant of y1 y2 y3 y1 dash y2 dash y3 dash y1 double dash y2 double dash y3 double dash, and this d is called as Wronskian of this. Okay, and d is called as Wronskian. Now we'll see first example depending upon the variation of parameter. Solve this example by method of variation of parameter. Now in this method, you must have to find out the correct YC. If your YC is wrong, then definitely your YP will also wrong, because if you see that your totally YP is depending upon the YC. Your YP is depending upon YC. Okay. So d square plus 1 of y is equal to x into sin x. So how will go? So d square plus 1 of y is equal to x into sin x. So first of all auxiliary equation is. So what is our auxiliary equation? Our auxiliary equation is, here we will find out the roots. Auxiliary equation is d square plus 1 is equal to 0. So which implies d square is equal to minus 1. So d is equal to plus or minus I. Okay, d is equal to plus or minus I. Now the roots are complex. So we can write yc as yc is equal to c1 cos x plus c2 sin x. Here alpha is equal to 1. Sorry, alpha is equal to 0. So e raised to 0 is 1. So e raised to 0 into bracket c1 cos beta x. Here beta is equal to 1. So c1 cos x plus c2 sin x. Now you see the general form of this. Now once you got yc is equal to c1 y1 plus c2 y2, then your particular integral yp is equal to u into y1 plus v into y2. Okay, now here your your yp is, y1 is, so yc is equal to c1 y1 plus c2 y2. So comparing with this, here your y1 is cos x and y2 is sin x. Okay, here y1 is cos x and y2 is sin x. So we can write here just write down here y1 and y2. So your yp is equal, y1 is equal to cos x and y2 is equal to sin x. Okay, we will see yp. So what is our yp? Yp is equal to uy1 plus vy2. Yp is equal to uy1 plus vy2, that is yp is equal to u into cos x plus v into sin x. Okay, where u is equal to minus of integral of y2 into x upon d, and v is equal to integral of y1 into x upon d. How we calculate u and v? By using this formula. U is equal to minus of integral of y2 x upon d, and v is equal to integral of y1 of x upon d. Now, what do you mean by d? D is the Wronskian of y1, y2, y1 dash, y2 dash. Okay, so what is our y1 here? Y1 is cos x, y2 is sin x, and y1 dash is minus sin x, y2 dash is cos x. Now just take the determinant of this. So cos square x minus of minus sine square x, which is equal to cos square x plus sine square x. Okay, so your value of d is equal to 1. It means determinant of this y1 and y2 is equal to 1. Okay, now we will calculate u. I hope you are clear here. See, once again you will see here your YP method of to finding out the solution for the given differential equation by using method of variation of parameter. First of all, we will find out YC. So Y is given, auxiliary equation is your d square plus 1 is equal to 0. So d square is equal to minus 1. So d is equal to plus or minus I. Now when the roots are complex, you can write YC as C1 cos x plus C2 sin x. So YC is equal to C1 Y1 plus C2 Y2. So your Y1 is equal to cos x and Y2 is equal to sin x. Okay, your y1 is equal to cos x and y2 is equal to sin x. Now we will see if our y2 is equal to sin x, then see our formula for the yp is uy1 plus vy2 and yp is equal to uy1. Here y1 is equal to cos x, y2 is equal to sin x. So you will get u is equal to minus integration of y2 into x upon d, v is equal to integration of y1 into x upon d, where here d is equal to determinant of y1 y2 y1 dash y2 dash. So here cos x sin x minus sin x cos x. So cos square x minus of minus sin square x, that is cos square x plus sin square x. Okay, so your value of d is equal to 1 here. Now we will calculate u here. U is equal to minus of integral of y2 into x upon d. Okay, just put all the values minus of integration of, here y2 is your sin x. So sin x into x. What is our x? X is x into sin x. Into x into sin x upon d. D is 1 into dx. Okay. Yeah, d into x, so dx, you will get dx here. So what is our dx? You will get here sin x into x sin x upon 1 dx. So is it nothing but minus into x into sin square x dx, minus x into sin square x dx. So minus x into sin square x here. So we know that we cannot calculate directly the formula for sin square integration for this sin square x. So what we will do? We will use the identity for this sin square x. As we know that sin square x minus of x into sin square x is 1 minus cos 2x by 2. Now, if you see here, sin square x is 1 minus cos 2x by 2 into dx. Now, just take 1 by 2 outside. So, you will get minus of 1 by 2 into integration of x into, I am multiplying, see, 1 by 2 into x. So, take 1 by 2, 1 by minus 1 by 2 into x dx. Now, this minus and this minus 1 by 2 becomes plus 1 by 2 into integration of x into cos 2x. I hope you are clear this time. Okay, so 1 minus 1 by 2 into x dx plus 1 by 2 minus minus sign this plus 1 by 2 into x into cos 2x dx. Okay, so x into cos 2x dx, now separate out, integrate. So you will get yp is equal to minus 1 by 2 integral of x dx. So integration of x dx is, so I am writing here just first and then we will simplify it, plus 1 by 2 into integral of x into cos 2x dx. Okay, now see. So minus 1 by 2 integration of x is x square by 2. plus 1 by 2 into integration of x into cos 2x. So retain the first. See, u into v with rule we will apply. Okay. So u into v rule by parts. Here we will use by parts. So u into v rule LIATE. LIATE. First is logarithmic, inverse trigonometric, algebraic, trigonometric and exponential. So here x is algebraic, so that is our u, and cos x is trigonometric, so that is our v. So here we can use u into v rule of the integration. Okay. So in u into v rule of integration, that is retain the first or integral of what is our by parts, uv dx is equal to u into integral of v dx minus integration of d by dx of u into integral of v dx into dx. Okay, I will apply the same thing over here. Okay, here your x is u and v is cos 2x. So u into integral of cos 2x dx minus integration of d by dx of u. So what is our u? X into integral of v cos 2x dx into whole dx. Okay, I hope you are clear this rule, how I applied it here. So here you will get minus x square by 4 plus 1 by 2 into bracket. Now x as it is, so integration of cos 2x is sin 2x upon 2, integration of cos x is sin x. Okay, so here you will get x by 2 into sin 2x plus minus integration of derivative of x with respect to x is 1 into integral of cos 2x, it means sin 2x by 2 dx. Okay. Now I hope you are clear here. Okay, now integration of this. Now we will integration of this. So minus x square by 4 plus 1 by 2 into x sin 2x upon 2 minus, here integration of sin 2x, see 1 by 2 is constant outside, integration of sin 2x is minus cos 2x upon derivative of 2x, that is 2. I hope you are clear here. Okay. Now this is simplified manner. So you will get yp is equal to, I am writing in a very simplified way, minus x square by 4 minus x square by 4 plus x by 4 sin 2x plus x by 4 sin 2x minus 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 plus cos 2x by 4 plus cos 2x by 4 minus minus plus cos 2x by 4. Okay, now this is your yp. Now see, your cos 2x by 4 and this 1 by 2. We forgot to multiply this 1 by 2, that is 1 by 8 here. So cos 2x by 8 here. Okay, I hope you are clear. So minus x square by 4 plus x by 4 into sin 2x plus cos 2x by 8. Now this is our y, not yp actually. This is our u. It's our usual practice to calculate yp. So here u. I'm extremely sorry. Here we will write u. Now this is our u. Okay. Now we will calculate v. So what is our v? V is equal to, see here, integral of y1 into x upon d. Okay. So integral of y1 into x upon d. So here integral of your y1 is cos x into x is x sin x upon d, it means 1 into dx. Okay, so what we will do here, integral of x into sin x into cos x dx. So to simplify this, I will multiply it by 2 and divide by 2. So 2 sin x cos x, it means sin 2x. Now your integral becomes simple. X into sin 2x. Formula for sin 2x is sin x into cos x. 2 sin x into cos x. So I am using that formula here to elaborate it very simple manner. So 1 by 2 into integral of x into sin 2x dx. Okay, so 1 by 2 into integral of x into sin 2x dx. So v is equal to this. Now just integrate. Again here we will apply. Again here we will apply. So shall I rub this? So your u is equal to this. Okay, so we will calculate v is here. So 1 by 2. So I am using again the by parts rule here. Retain the first into integral of this. So integral of this is minus cos 2x by 2. Okay, minus u into integral of v dx minus integration of derivative of u. That is 1 into integral of this. So minus cos 2x by 2 dx. Okay, so this minus becomes plus. The integration of cos 2x is sin 2x by 4. Okay, so we will get v as v is equal to, I'm roughing out this, so v is equal to 1 by 2 into minus x by 2 cos 2x. Now this minus and this minus becomes plus, and integration of cos 2x is sin 2x by 4. This 2 are again. Okay, so your v becomes minus x by 4 cos 2x plus sin 2x by 8. This is our v. Okay, so once I got u and v, so can I write as here our yp is equal to uy1 plus vy2. Okay, so u is our minus x square by 4 plus x by 4 sin 2x plus cos 2x by 8 into y1. y1 is our cos x plus minus x by 4 cos 2x plus sin 2x by 8 into y2, that is sin x. This is our yp only. You can write our final answer y is equal to yc plus yp. That will be your complete solution for the given differential equation by using method of variation of parameter. Okay, so I'm writing here our final answer, that is y is equal to yc plus yp is here. Plus x by 4 sin 2x plus cos 2x by 8 into cos x into cos x plus minus x by 4 into cos 2x plus sin 2x upon 8 into sin x. This is our final answer, y is equal to yc plus yp. Okay, this is our final answer. Y is equal to YC plus YP. Okay, now next example we will see. Okay, this is very interesting example. T square plus 9 of y is equal to 9 cot 3x into cosec 3x by variation of parameters. Okay, d square plus 9 of y is equal to 9 cot 3x into cosec 3x by variation of parameters. So we can use that variation of parameter here. So d square plus 9 of y is equal to 9 cot 3x into cosec 3x. So you will get, first of all, find out yc. D square plus 9 is equal to 0 is the auxiliary equation. So which implies d square is equal to minus 9, which implies d is equal to plus or minus 3i. I hope this step is very simple. So d is equal to plus or minus 3i. So roots are complex. So we can write here yc is equal to e raised to alpha x, but here alpha is equal to 0. So e raised to 0x, it means e raised to 1. Okay. So here e raised to 0, we will get c1 cos 3x plus c2 sin 3x. c1 cos 3x plus c2 sin 3x is our c1 cos 3x plus c2 sin 3x is our alpha. This is our yc. Now what is our y1? Here y1 is equal to cos 3x, y2 is equal to sin 3x. So we will have our yp is equal to uy1 plus vy2. Okay, so here y1 is equal to our u into cos 3x plus v into sin 3x. Okay, so we will calculate u is equal to, here our u is equal to integral of minus of y2 into x upon d dx. V is equal to integral of y1 into x upon d dx. Okay, so we can calculate here d first. So what is our d? D is equal to y1, y2, y1 dash, y2 dash. So here y1 is cos 3x, y2 is sin 3x. Cos 3x, sin 3x. So y1 dash, it means here you will get minus 3 sin 3x. Here is 3 cos 3x. So determinant of this is 3 into cos square 3x minus, and this minus minus plus 3 into sin square 3x. So you will get 3 into bracket cos square 3x plus sin square 3x. Right? So you will get 3 into bracket cos square 3x plus sin square 3x is equal to 1. So here value of d is equal to 3. Right? Now, once we get this, we can find out u. So u is equal to minus integral of y2 into x upon d. So which is equal to minus integral of, what is our y2? Y2 is sin 3x into, now very interesting is here, our x is 9 cot 3x into cosec 3x. बच्चे क्या करते हैं, इतना बड़ा x देख के एग्जाम्पल वहीं पे छोड़ देते हैं, बट यहाँ पे मैं आपको बता दूं कि अगर आपको डिफरेंशियल इक्वेशन सॉल्व करना है ना, सो यू मस्ट नो the derivatives and integration. So that part must you have to clear it first. So what do you mean by derivatives, and what are the derivatives of some standard functions and integration of some standard function, as well as you must know how to apply the by parts. So I have given one session on the by parts also, you can go through it. See, minus sine 3x here, minus y2 is sine 3x into x is 9 cot 3x into cosec 3x. 9 cot 3x into cosec 3x dx. Okay, upon d. Upon d it means here 3. So what will becomes your integration here? Now see this 9, this 3. So 3 3s are 9. So I am taking 3 outside. Now sin 3x into cot 3x. Sin 3x into cot 3x into cosec 3x dx. Okay, very simplified manner we will write here. So minus 3 into integral of, now if you observe here sin 3x and cot 3x and cosec 3x. Okay, so sin 3x into cot 3x, can I write here cos 3x upon sin 3x into cosec 3x, can I write here 1 upon sin 3x. So that is our cosec 3x, right? So cosec 3x and cot 3x. So you will get here, see, this sin 3x and this sin 3x will get cancelled out. So ultimately you will get minus 3 into integration of cot 3x dx. Now it's a very simple to find out the integration of cot x. So what is the integration of cot 3x is, integration of cot x is log of sin x. So minus 3 into log of sin 3x upon derivative of 3x, that is 3. Okay, so we will get minus 3 plus 3. This 3 will get cancelled out. So minus log of sin 3x. This is our u. I hope you are clear. Here I am explaining once again how to calculate the u here. U is equal to minus of integral of y2 into x upon d. So just put the value of y2. Your y2 is sin 3x and here x is given 9 cot 3x into cosec 3x. Okay, so d is, we already calculated value of d is here, d is equal to 3. Okay, so minus 3 into integral of sin 3x into cot 3x into cosec 3x dx. So it is equal to minus 3 into integral of sin 3x into, now this sin 3x and cosec 3x, because cosec 3x is 1 upon sin 3x, or sin 3x we can write 1 upon cosec 3x. So sin 3x get cancelled out. You will get minus 3 into integral of cot 3x. What is the integration of cot x? Integration of cot x is log sin x. So here integration of cot u, it is log u upon derivative of u. So derivative of u here, derivative of 3x is 3. So log sin 3x upon 3. So 3 get cancelled out. So here u is equal to minus log sin 3x. Okay. Now we will move forward. So you will get here v. Now we will calculate v. Okay. So what is our v? V is equal to integral of y1 into x upon d dx. Okay. So we will calculate here integral of, what is our y1? Here y1 is cos 3x. Cos 3x into 9 cot 3x into cosec 3x. Just we will see once again. 9 cot 3x into cosec 3x upon 3 dx. Again 3 is here. So you will get 3 outside. Integration of. Now see cos 3x. So you will get cos 3x into cot 3x. Can I write here? Cos 3x upon sin 3x. Right? And cosec 3x. Can I write here? Sin 3x. So this will become cos square 3x upon sin square 3x. There is no any cancellation term. So can I write here is cos square 3x upon sin square 3x dx. So cos square 3x upon sin square 3x is nothing but 3 into integration of cot square 3x. Now, there is no direct formula for the cot square 3x, integration of cot square 3x. So, what we will do? We will write here v is equal to integration of 3 into cot square 3x dx. Now, see here, integral of cot square 3x. But can I convert this cot square? We have a formula for direct cosec square 3x. So can I write this as integration of cot square 3x? Can I write this as cosec square 3x minus 1 cot square 3x? It means cot square 3x. It means can I write directly here cosec square 3x minus 1? So integration of cosec square 3x is 3 into integral of cosec square 3x minus 3 into integral of 1 dx. So 3 into integral of cosec square 3x. So what is the integration of cosec square 3x? Integration of cosec square 3x is log of log of minus cot of 3x upon derivative of 3x is 3 minus 3 into integration of 1 dx is x. So this 3 get cancelled out. So you will get minus cot 3x minus 3x. This is our v. Okay. Now we will get our yp is equal to uy1 plus vy2. Okay. So you will get yp is equal to u is minus log sin 3x minus log sin 3x. Okay, and y1 is cos 3x plus v into y2. So our v is minus cot 3x minus 3x into y2. y2 is sin 3x. Right? This is our v. So this is our u and this is our v. So we will get yp is equal to this. Now we can write final answer. Y is equal to yc plus yp. So what is our yc? c1 cos 3x plus c2 sin 3x. c1 cos 3x plus c2 sin 3x minus cos 3x into log of sin 3x. Okay, minus or plus minus cot 3x minus 3x into sin 3x. This is our y. So this is our complete solution. Okay, this is our complete solution by using method of variation of parameter if the order of the differential equation is 2. Okay, now we will see one example in which the order of this differential equation is 3. Here order of the differential equation is 3. Now see how we will solve this. Order of the differential equation is 3. When the order of differential equation is 3, how to find out the solution for this differential equation. Okay, so d cube y upon dx cube plus dy by dx is equal to tan x. So you will get d cube y upon dx cube. So first convert, put d by dx is equal to capital D. And first convert d by dx is equal to capital D. So you will get here d cube y plus dy is equal to tan x. So you can take y common. So d cube plus d of y is equal to tan x. Okay. So auxiliary equation is d cube plus d is equal to 0, which implies d into bracket d square plus 1 is equal to 0, which implies d is equal to 0 or d square plus 1 is equal to 0, which implies d square is equal to minus 1, which implies d is equal to plus or minus r. Okay, now this is a cubic or this is a differential equation of order 3. So you will get d is equal to plus or minus I. So as d is equal to plus or minus I, we will see, we can write here yc as here roots are d is equal to 0 and d is equal to plus or minus I. One root is real and the two roots are complex. Okay, one root is real and other two roots are complex. So we can write yc as yc is equal to c1 e raised to 0x plus e raised to alpha is 0 here. So e raised to alpha x, it means e raised to 0x is 0. So c1 e raised to 0x plus c2 cos x plus c3 sin x. Okay, so e raised to 0x is 1. So your yc is equal to c1 plus c2 cos x plus c3 sin x. So you can write yc as c1 y1 plus c2 y2 plus c3 y3. So here y1 is equal to 1, y2 is equal to cos x and y3 is equal to sin x. We will cover up this. Yes, see the general form for the if yc is equal to c1 y1 plus c2 y2 plus c3 y3, then yp is equal to uy1 plus vy2 plus wy3. For that we require u, v and w. So how we calculate u? U is equal to integral of determinant of y2 y3 y2 dash y3 dash into x upon t, and v is equal to minus of integration of y1 y3 y1 dash y3 dash into x upon d dx, and w is equal to integration of determinant of y1 y2 y1 dash y2 dash x upon d dx. Okay, so where d is equal to Wronskian of y1 y2 y3 y1 dash y2 dash y3 dash and y1 double dash y2 double dash y3 double dash, that we will calculate first. So here we will calculate d first. So our yp is equal to uy1 plus vy2 plus wy3. Okay. So for that we require u, v and w. So we will calculate first d. So our D is equal to y1, y2, y3, y1 dash, y2 dash, y3 dash, y1 double dash, y2 double dash, y3 double dash. Okay, so which is equal to y1 is 1, y2 is cos x, y3 is sin x. Okay, so derivative of 1 is 0, here is minus sin x, here is cos x, here is 0, here is minus cos x, here is minus sin x. So we can calculate D. So determinant of this is 1 into bracket minus minus plus sin square x minus cos square x. So this minus and this minus becomes plus cos square x minus cos x into bracket 0 minus 0 plus sin x into bracket 0 minus 0. So your D becomes D into bracket sin square x plus cos square x is 1. And this 0 and this 0 becomes 0. So your value of D is equal to 1. Okay? Your value of D is equal to 1. Now we will calculate, as it is value of D is equal to 1, we will calculate U. So what is our U? U is equal to integral of determinant of y2 and y3, y2 dash, y3 dash. If you are calculating U, skip y1, take y2, y3. Okay? y2, y3, y2 dash, y2 and y3 dash into x upon d dx. Okay? That is equal to x into determinant of, what is our y2? Cos x, y3 is sin x, y2 dash minus sin x, y3 dash cos x. Okay? Up into x. What is our x? X is tan x upon d. D is equal to 1 into dx. Okay. So u is equal to integration of, calculate the determinant of this, cos square x minus of minus, it means plus sin square x. So your determinant becomes 1. So it is only tan x dx. I hope it is simple to understand here. Integration of tan x is log of, you will get sec x. Okay. So u is equal to our, here u is equal to log sec x. Now see once again how we calculated it. U is equal to integral of determinant of y2, y3, y2 dash, y3 dash into x upon d into dx is equal to integral of determinant of cos x into sin x. Determinant of cos x, because y2 is cos x, y3 is sin x. y2 dash is minus sin x and y3 dash is cos x. So into tan x dx. So u is equal to integral of, here determinant of this is equal to 1. So only tan x dx. So integration of tan x dx is log of sec x. Okay. So once we get this, we will calculate v. Okay. So v is equal to minus of integration of determinant of, I'm telling you one trick how to remember. If you are taking v, skip y2. See, y1, y2, y3, u, v, w. If you are taking v, then skip y2. If you are taking u, skip y1. If you are taking w, skip y3. Okay. So here you will get minus of integration of y1, y3, y1 dash, y3 dash into x upon d dx. Okay. So minus integration of, here y1 is equal to 1, y3 is sin x, y1 dash is 0, sin x, derivative of sin x is cos x, into x is tan x upon d is 1 into dx. Just put everything whatever you have with you. So minus integration of determinant of x the determinant of this. So minus of integration of, what is the determinant? Cos x into, you will get cos x minus sin x. So cos x into 0. So you will get a determinant of this is cos x into tan x. Okay. So cos x into tan x you will get. So ultimately, what do you mean by tan x? I will use simple way. Sin x upon, here sin x upon, here you will get sin x upon cos x. So cos x cancel out dx. So minus integration of sin x. So integration of sin x is cos x minus cos x. So you will get minus cos x and minus sin. Minus of minus cos x is equal to cos x. So your v is equal to cos x. I hope you are clear here up to this step. Okay, what you mean by v? V is equal to cos x. So once you are getting v is equal to cos x, we will calculate our w. So what is the formula for w? W is equal to integration of determinant of, here, determinant of y1, y2, y1 dash, y2 dash, okay, into x upon d dx. So integral of determinant of y1, y2 is cos x, y1 dash is 0 and y2 dash is minus sin x, into x is tan x into dx, d is 1. So integral of, what is the determinant of this? Minus sin x minus 0, so minus sin x. Minus sin x into tan x dx. Okay. So minus of integral of sin x upon cos x dx. Okay. So this will becomes minus of integration of sin square x upon cos x dx. So can I write sin square x as 1 minus cos square x? See, w is equal to minus of integration of 1 minus cos square x upon cos x dx. Right? 1 minus cos square x upon cos x dx. So here w is equal to minus of integration of 1 upon cos x dx minus minus plus integration of, now cos square x, this minus I am separate outing this, minus minus becomes plus, and integration of cos square x upon cos square x means integration of cos x dx. Now w is equal to minus integration of 1 upon cos x is nothing but sec x dx plus integration of cos x dx. Right? So w is equal to minus integration of sec x is log of sec x plus tan x. Okay, integration of sec x is log of sec x plus tan x. So minus of log of sec x plus tan x minus log of sec x plus tan x plus integration of cos x is sin x. Okay. Here you are getting integration of cos x is sin x. So ultimately you will get w is equal to this. So what is our yp? Yt is equal to uy1 plus vy2 plus wy3. So we can write yp as, here we will see yp is equal to u. What is the value of u? What is the value of u here? We have calculated here u is equal to log sec x. log sec x into y1. So what is our y1? Y1 is 1 plus v. V is cos x into y2 is our y2 is also cos x. So cos x into cos x plus w. W is minus of log plus minus of log of sec x plus tan x plus sin x into sin x. Y3 is sin x. Okay, so that you can write down final answer y is equal to yc plus yp. So write down you both y is equal to yc plus yp here. So your yc is, I'm writing down this. So your complete solution will be, so your complete solution will be your complete solution y is equal to yc plus yp. So what is our yc? Yc is c1 plus c2 cos x plus c3 sin x plus yp is log of sec x plus cos square x minus log of sec x plus tan x into sin x plus sin square x. Okay, so if you see here cos square x plus sin square x, so ultimately your y becomes, y is equal to c1 plus c2 cos x plus c3 sin x plus log sec x plus cos square x plus sin square is equal to 1 sec x plus tan x into sin x plus 1. Okay. So this is our final answer. I hope you are clear how to calculate the, oh sorry, I hope you are clear how to calculate the solution for the given differential equation by using method of variation of parameter. Today we completed our all the methods, that is in last lecture we have seen how to find out the solution by using general method, and we covered up 3 rules in the last lecture, and in this lecture we cover up the remaining 3 rules. Now there are 3 methods to calculate the solution for the differential equation. First is general method, then second is shortcut method. In that shortcut method there are 6 rules, so we will apply the 6 rules in a different ways. Okay, and then third method is a method of variation of parameter. In that again there are 2 cases. If the order of the differential equation is 2, then how to calculate the solution for the differential equation, and if the order of the differential equation is 3, then how to calculate the solution for the given differential equation. I hope you are clear each and every point of the differential equation. I took cover up everything in these 2 lectures. Okay, from your differential equation, if you go through it, then definitely you will get out of marks for the, I'm especially for, I'm telling you for the engineering mathematics 3. Okay, this is our first unit from from your M3, that is differential equation. linear differential equation with constant coefficient. I cover up each and every type in this lecture, and the remaining two types are, there are two types are remaining, that is Cauchy's differential equation and Legendre's differential equation, that we will see in the next lecture how to convert it into the given Cauchy's differential equation into linear differential equation with the substitution, and given Legendre's differential equation, we will convert it into linear differential equation with constant coefficient, and we will apply the same rule in that lecture. In the next lecture, we will cover up also the examples are given in any way, so you have to think on it that which rule is applicable for that example. Okay. So I hope you are liking my videos. So please do share, subscribe and likes. So thank you so much. Thank you so much for the watching.